Hello guys, welcome to another video. Today we are going to solve another question, that is count inversions. It states that for an array, inversion count indicates how far or close the array is from being sorted. Basically, there is a condition that tells you that there is an inversion in the array. That condition is if a of I is greater than a of j, where I is less than j, then there is an inversion. Let's take this example and see. Here, with the help of this example, I will show you how you can use this condition to count the inversions. Let's say we are starting I from here and we have started j here. We can match a of I is greater than a of j here. No. Then the j will come here. Now 2 is greater than 1. Then there is one inversion, 2 comma 1 we have got. Now we go to the next position. Here it is not greater than a of j. Then we go to the next position. 2 is not greater than 5. Then we are gonna move I to the next position. Now I comes here and j is here. 4 is greater than 1. Then this is a pair. 4 comma 1 is also a count inversion. Then j comes to this. Now 4 is greater than 3. Yes. Then 4 comma 3 is also a inversion pair. Count increases. Now 4 comma 5, this is not a pair because 4 is not greater than 5. Now I will move to the next position. Now if we check 1 is not greater than 3, j will move to the next position. 1 is not greater than 5. Then there is no pair. Now we move to the next position. I comes here, j comes here. 3 is not greater than 5. Now move to the next position. I is here and there is no position for j. Then this array is traversed and we have 3 count inversions here. So the output is 3. So there is a brute force approach and an optimal approach. The brute force approach is the same approach that I used here to count this inversion count. But the total time complexity of this algorithm is n square because we are linearly traversing whole array. Now what is the optimal approach? The optimal approach uses merge sort. Basically, merge sort is dividing the array in two parts up till you get a single unit out of it. When you get that single unit out, then you are gonna do backtracking and sort the array. For example, 2, 4. It is already in sorted order, so 2, 4 comes here. Now for this pair, 1 is actually smaller, so the new array will become 1, 2, 4. Here 3, 5 is actually the real array because it is already sorted. Now here in this position, the new array will become 1 will come here, 2 will come here, but 4 is greater, so 3 will come here. After that 5 is greater, so 4 will come here, and then 5 will come here. This is the merge sort technique that we are going to use, but we are going to modify it a bit so we can count the inversions. So we are going to start with this pair. I will be here, j will be here, and after that we are going to start. Is a of I greater than a of j? No. So we are going to form this pair. I will come here, and after that there is no value, so we will put j here. Now for this pair we will start again. I will come here, j will come here. Is a of I greater than a of j? Yes. So we are gonna increment it by 2. Why 2? Because we have 2 elements from I and we know this sub array is already sorted. So whatever the value is after 2, it is already bigger. It will be greater than a of j. So it doesn't matter. We are gonna count that whole array. Now we will put 1 here. Now j is out of bounds. So we will put everything in this array up here, 2, 4. Now for this pair, we need to first solve this pair. I is here, j is here. A of I is not greater than a of j. So 3 will come here as it is. I is out of bounds. So we will put j here, that is 5. Now for this pair and this pair, we will start from here, I and j. A of I is not greater than a of j. So we will put 1 here. I will come to the next place. 2 is not actually greater than 3. So we will put 2 here and I will go to the next place. 4 is actually greater than 3. Now we will count how many places are there after I. and including I. There is only one, so we will count inversion increases by 1. Now we will put 3 here and j will come to the next place. Now 4 is not greater than 5. We will put 4 here, but I becomes out of bound. Then we will put j, the value 5 here, and j is also out of bound, and we got the new array which is sorted, and we also got the count inversion count. So the total output is 3, and the time complexity for this algorithm is big of n log n. Yes, because we are using merge sort, which takes actually n log n, and the space complexity for this algorithm is big of n, because we are going to use temporary arrays whenever required. Now we can look at the code that is required to solve this question. First, we take a look at merge sort, which is returning long. So this question was not available at Leetcode, so we are using GFG for this question, and in GFG everything is passed in long. So we are going to use long for every operation. You can use whatever you are given in the interview. So first we'll take a look at the merge sort. Merge sort, we are given an array left and right. So we have introduced a new count variable which will count the inversions here. Otherwise we don't have anything in merge sort. We just use the function for sorting the array, but we have to return the count, so we have introduced a new variable count here. First we get the mid of that array, which is basically left plus right divided by 2. After that we use this mid to actually divide the array into two parts. So here we are actually dividing the array in two parts with the use of recursion, and we are passing array with left and mid plus 1 to the right. Basically, so every element from left to mid will be passed in the first size, and second will take up the last remaining array. And after these elements are passed, we are actually merging the array in the last iteration. For every operation that we are doing, we are actually increasing the count whatever we have got from that operation, so we can track count here. Now let's look at the merge part. The merge part, first we have to find the sizes of the array that we have gotten. Basically, the first size will be left to mid, and second size will be from mid to right, right? So here we use mid minus left, so we have got the value of n1, but we want the mid to be included in the first array, so we are doing plus 1, and we want the remaining array to be part of n2, so we have done right minus mid. So we have got the size of the second array. Now we create two temporary arrays left and right to hold the values of left array and the right array, and we just use this function to copy everything into the left array and the right array from the real array. After we have got everything into the left array and right array, we need to create some variables, that is I, j, k and count. I and j will be used for iterating through left and right array. K will be used in the real array to fill up, because we are starting from the left side, right? The first value or the first index is actually left, so we have introduced k, which is holding the value of left, and we need to count the inversions, so we have introduced a count variable. Now in this while condition, we are checking if I is less than n1 and j is less than n2. This is the condition to check if we are getting out of bounds or not. If we are getting out of bounds, then it is no use to copy the array. The first condition is we are checking left array, means a of I in the condition here L of I is greater than right side of the array. If that is greater, then we need to count whatever is left in the array. That will be mid plus 1, because there are mid plus 1 variables, meaning we are also including the mid variable here. And we are subtracting the iterated values, which is basically I, and the index we have started is left. So this will give you the real count whatever is remaining in the array. So we are just adding that to the count. After that is done, we are just simply copying the value of right side of the array to the real array. And after that is done, we are just increasing the count of j. We also need to increase the count of k, but that is done in the last, because for both the condition k will be increased. Now, in the else part, we know that we don't need to count because there is nothing that is actually making count inversion variables or pairs. So we just copy the array from the left side and just increase the value of I. We are checking if there are some variables in left side. If there are some variables, we are just copying that left array to the remaining part of the real array. Or if there are some variables remaining in the right side of the array, we are doing the same. And after that is done, we are returning the count. And that's how we are counting the inversions that we have encountered. And we are just passing that to the real method that has called this method merge, which is merge sort, and we are getting the total count and we are returning that total count to the function. And to actually use this merge sort function, we have to pass the array from starting from 0 to n-1. n-1 because we need the last index, not the whole length. And why are we cloning this temporary array? Because this array will be changed, meaning this array will be sorted by merge sort. And if by any chance your recruiter or interviewer says you don't need to modify the array, then what you have to do is take a temporary array and pass that along instead of directly modifying the real array. If you really like this explanation, please give a thumbs up and also share this video as much as possible. And if you have any questions, please let me in the comments below. Thank you guys. Let's meet in the next video.